Hi everyone, and welcome back to the class of collisions that we were dealing with. Okay, so in the last class we went over the concept of elastic and inelastic collisions and how the momentum has to be conserved in the collisions. So today we are going to apply that knowledge on the question. So let's look at what we have at hand. We have a 113 kg football tackler moving at a speed of 3.1 meters per second. It collides head-on with a 87 kg halfback moving at a speed of 4.8 meters per second. Now remember, the collision is head-on. Okay? Assuming they stick together, what is their new velocity immediately after the collision? So let's put the thinking caps on and let's get to work. Okay, so let's work out together. Okay, what would be the first step? Yes, we need to make two columns, before collision and after collision. Perfect. That's right. Now we are going to write what is given to us. So in the column of before collision, what information do we have? Yes, we know that M1 equals 113 kg. Perfect. V1 3.1 meters per second, that's right. Okay, M2 87 kg. Okay, what else? Okay, V2 4.8 meters per second. Let's look back and see if we are missing something. No? Let's think about it again. What we have here is a football tackler and a halfback. The collision is head-on. What that means, that if the football tackler is going towards the right, the halfback would be coming towards the left. We are dealing with velocities. Velocities are vectors. They have magnitudes and, yes, now I hear that, direction. So we have two things. So if V1 we are taking as positive, that means our V2 would be negative. That's right. So let's put a negative here. We have negative 4.8 meters per second. Good job. Now let's move on to what happens after the collision. After the collision, they stick together. So our mass is the total mass. That's right, which would be M1 plus M2, and that should be 113 plus 87. If someone can give me the answer, what would that be? That's perfect, 200 kg. Is there any other information that's given to us? No. Okay. Now that's given. Now let's write down what is unknown. What do we need to find? What do we need to find? That's right. We need to find the effective velocity after the collision. That's the unknown. Okay, so now we need to know what equation we need to use. Anyone? That's right, conservation of momentum. Momentum before should be equal to momentum after. Perfect. Okay, so now what would be the momentum before? What is the formula for momentum? Can I hear that? That's right, P equals mv. So let's apply that. So we have m1 v1 plus m2 v2 should be equal to, that's correct, total m multiplied by, yes, v after. Okay, now let's execute. Now let's plug in all the numbers that we know. Okay, 113 times 3.1 plus 87 times negative 4.8, that's right, equals 200 times V after. Okay. Okay, so let's do the calculations now. So 113 times 3.1 gives us, perfect, 350.3. 87 times 4.8, that's right. Yes, we do have a negative sign here. I'm glad you noticed that. So negative 417.6 times 200 V after. Now what should be the next step? Yes, so we need to solve the left hand side first. What do we get? That's right, even I got negative 67.3 equals 200 V after. Yeah, dividing both the sides by 200, we get V after, yes, as negative 0.3365. Okay, that's correct. Yes, we can write it as negative 0.337. What should be the units? Meters per second. That's perfect. So now what does this negative imply? Any ideas? Yes, so this negative shows that after the collision, they are moving towards left. Yes. So negative tells us about the direction. And the magnitude is 0.337 meters per second. Okay. Okay, so that would be all for this question. Any questions? Any doubts? No? All right. You did great. Perfect. Have a good day.